continue. Bad fit. Okay. Let us create an example where polynomial regression would not be the best method to predict future values. So, for example, this x and y. Okay. This is polynomial regression. You are going to draw a line. Okay. You draw scatter plot and you plot the line and you chose. Okay, by observing the scatter plots, the data points in the scattergram. So it's difficult to draw a linear line, straight line, or even difficult to draw a polynomial line. So it's like this. Okay, to confirm that it's scatter, okay, you compute R square values. Okay, you compute R square values. Okay, and this is you compute R square values. Okay, the values is 0.009. It almost 0. Okay, it almost 0. So we can conclude that it's a bad fit, and polynomial regression may not be a good choice. Okay, for solving these problems. Okay, we can go for other techniques, another techniques. Okay, in regression we call it multiple regression. Okay, go for multiple regression. Okay, or we use some other techniques in machine learning. Okay, but let's have a look at multiple regression. Okay, multiple regression is like a linear regression, but with more than one independent values, meaning that we try to predict a value based on 2 or more variables. Let's take a look at the data set below. It contains some information about cars. Okay, in Python, we have modules that we do the work for us. Start by importing the Panda modules. Okay, we learn how to use some many modules. I mean, okay, and we are going to learn just one of several important features of Panda. Okay, modules in here, multiple regression in Python. So you can just import Panda. Okay, from scikit-learn, import linear model. Okay, and the Panda modules. Okay, in this example, Panda modules allow us to read the CSV files and return a data frame object. Okay, the file is meant for testing purpose only. You can download it here. So this is car.csv. You can find car.csv in the folder regression. I just prepare the Excel file for you in the folder regression. Just regression. Okay, car.csv here. You can just open. What does it look like? See the data set in the Excel file. We have cars, model, volumes, how many cc, right? 1000 cc, 1 liter engine. Okay, weight of the car, and carbon dioxide, CO2 emission of each car model. Okay, 1, 2, 3, 4, 5 parameters. Okay, like in the Excel files. And then you make a list of independent values and call this variable x. Okay, x. All right. df is the variables. Okay, you read. Okay, you read the data from car.csv. Okay, and save the data into the df variables. So, and x, okay, you call df variables. Okay, and you can just make a list of the independent variables. In this case, you just create the list of df weight and volumes. Okay, and y is the CO2 emission. Okay, put the dependent variables in a variable called y. Okay, this is multiple. Can you guess it why we call it multiple regression? Okay, linear regression and polynomial regression, we have only two variables, right? One independent variables and one dependent variables. But if you have more than one independent variables like this, in this case x, okay, you have two independent variables of x, weight and volume. So just applying multiple regression. Okay, from scikit-learn module, we will use the linear regression method to create a linear regression object. Okay, and this object has a method called fit that takes the independent and dependent variables as parameters and fills the regression object with data that describe the relationships. Okay, linear regression model dot linear regression. Okay, regression dot fit xy. So, and now we have a regression object that are ready to predict CO2 values based on a car weight and volumes. Predict the CO2 carbon dioxide emission of a car, where the weight is, you just predict where the weight is 2.3 2,020 kilograms and volumes is 1.0 liter engines. So, and then you can just predict the CO2. Predict the CO2. The value of the predicted CO2 emission is 107.20. Okay, you can use scikit-learn modules. Okay, and you can use linear regression method. Okay, to create a linear regression object. Okay, and call the fit method. Okay, that takes independent and dependent values as a parameter and fill the regression object with the data that describe the relationships. So we have predicted that a car with 1.3 liter engine and weight 2,300 kilograms will release approximately 107 grams of CO2 for every kilometer it drives. Okay, coefficient is the factor that describes the relationship with an unknown variables. So coefficient is a factor that describes the relationship between with an unknown variable. So if x is a variable, 2x is 2 times x is unknown variables. So the number of 2 is coefficient, just a number. Okay, we call the coefficient. But in this case, we can ask for the coefficient values of weight against CO2 and for volumes against CO2. The answer will tells us that what would happen if we increase or decrease one of the independent values. So okay, import panda df, you read the car.csv files x and y. Okay, you call linear model, linear regression. Okay, and then you fit x and y. Okay, you fit x and y. So you print the regression coefficient values. So in this case, you get coefficient value 0.007 and 0.078. Okay, the results array represent the coefficient values of weight and volumes. Okay, this coefficient of weight and volumes. Okay, and these values tell us that if the weight increased by 1 kilogram, CO2 emission increased by 0.0075 grams. And if engine size increased by 1 liter, the CO2 emission increased by 0.078 grams. Okay, fair guess. Okay, fair guess.